Hola. Hi, everyone. How's everyone doing this afternoon? I'm so glad to see that the energy is still up, even though it's end of the day. So let's jump into today's presentation, which is acing your coding interview. And let me get my clicker. So a little about myself. My name is Shubha Swamy. I'm a software engineer at Twitter. I primarily work on writing backend services to protect Twitter user data. And my pronouns are she, her, and you can find me on Twitter at Shubha Swamy, which is my first and last name with an extra Y at the end. But first, let's talk about why am I here today, right? So not too long ago, I was in your shoes. I was in college, and I think a lot of us got into computer science because we see the impact that technology has on us and the people around us every day. And I think for a lot of us, right, we want to be a part of that technological change that's happening in the world. But I think for me, the one thing I realized was that there was this gap between the theory of like computer science that I was learning in the classroom and what it took to break into the industry. So today I'll be talking about how to bridge that gap, right? And really helping you all demystify that process of how to ace your coding interview. And let's face it, because interviews are hard. You're putting yourself out there, you've got a time limit, and you have this problem to solve. And that can definitely pent up a lot of nerves. But not to worry, because today we'll be going over some strategies, and that coupled with some practice on your end, you'll be ready in no time. And the type of interviews we'll be focusing on today are primarily the coding questions that are algorithms and like data structure-based style questions that you often find in like bigger companies. But keep in mind that sometimes when you do have a technical interview, it might be like a systems-based design question. Sometimes it's like debugging code or maybe even a take-home project. But I think no matter what kind of interview you have coming up, you can definitely take away some tips from today. And what can you expect when you go into one of these interviews, right? I think the primary goal is really testing out your problem-solving skills. So essentially, the interviewer wants to get a gauge for like, what would it be like to work with you on the daily? So if you're given an ambiguous situation, how would you deal with this in your every like work day? Because essentially, as a software engineer, that's what you'd be doing every day at work. And I will say interviews do require a very solid fundamental understanding of data structures and algorithms. But this doesn't mean that you need to memorize any of it. I would just say have like a really good grasp and good understanding of the fundamentals, and maybe even things like understanding like time and space trade-offs. And we'll go over that later on. But the other thing to also keep in mind is that most of the time, interviews are quite language agnostic. So you can use whatever language you're most comfortable with, whether that's C, C++, Python, Java. Yeah, and then the other thing is probably the main aspect of it, which is really practicing your communication. Because the type of communication that these interviews require is often something that we're not used to in the classroom or even in the workplace, right? Because essentially what you need to do is talk out loud throughout your problem-solving process. And I do want to say that interviews aren't all or nothing. It's quite common to get stumped on a problem, but the main point is to just keep going. And we'll sort of go through some strategies on how to deal with that as well. And ultimately, keep in mind, interviews are not tricky puzzles. Even though sometimes the problems might be complicated, they're definitely not trying to trick you frequently. And this is the framework we'll be using for today. And the framework breaks into the following, which is a comprehend, think, plan, implement, test, and review. And along with using that framework, I'll also be using this example. So that way you can see how do we apply this theory that we're going over today to a practical problem that might show up on an interview. And the problem that we'll be using goes as following. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. So let's look at an example. So we have our input array nums. So our input array might look something like 3, 2, 4. And then we're also given a target value, in this case 6. And so for this problem, the output or the expected output would be 1 and 2. The reason being the values at the indices of 1 and 2, so that's 2 plus 4, add up to 6. And I found this problem off of LeetCode, which is a great website to practice these kind of problems. A lot of you might already be using it, but I'll go over more resources later on as well. So the first step is really understanding the problem truly before you jump into solving it. So how do you go about this? There's a few different methods. So the main goal of this step is really to truly clarify and understand the problem so that A, you can narrow the scope of the problem, and 2, make sure that you and your interviewer are on the same page of solving the problem. So one method is by repeating the question back. So by repeating the question back, you can make sure that you're really understanding the question for what it is, and if in case you misunderstand the question, the interviewer can correct you and put you back on the right course. Another technique is also asking lots of questions. So asking questions is really helpful because it really helps narrow down the scope of the problem, right? Because when a prompt is given to you, it can easily become a complicated problem that you need to solve. But the thing that we're trying to do is really just make it as easy or as simple as possible. So asking lots of questions is a great way to really narrow down that scope. Another method is also checking with test cases. And usually when the prompt is given to you, they'll also probably give you a question as an example. But this is also your opportunity to provide a couple test cases yourself. And again, providing those test cases will help you understand the problem better yourself. And also as you're going through the example, it'll help you craft that logic that you're going to use for your code later on in your mind. And when you do write these test cases, you can start with an easy case just to get it going, but I would also make sure to include edge cases. The reason is you definitely want to think about the corner cases that are involved in the problem, because later on when you write your code or even just write your logic, you want to make sure that you're incorporating all the different possible scenarios. And ultimately, you also want to clarify your expectations. So what does this mean? So I would just ask the interviewer, what are the expectations for today, if they haven't already mentioned it? Because sometimes the expectation might just be to simply write some code on the whiteboard. But especially these days with a lot of interviews being virtual, there is this increasing expectation of your code to compile and also pass a few test cases that they might give you. So what would this look like for this problem, right? So I think the first thing that I do is maybe jot a few bullet points down on the screen. So this is essentially my version of repeating the question back. So this is what I'd say to the interviewer. So what you're saying is that we're given a nums, which is an array of integers, and a target, which is another integer value. And what you're saying is that we need to return the indices of the two numbers that add up to target value. So at this point, you'll probably get some kind of confirmation from the interviewer to either go ahead, or if what I was interpreting this as was wrong, they would correct you. And then I would also ask them a few questions. So I would ask questions like, is it possible to have multiple solutions? And you might get something back like, you may assume that each input would have exactly one solution. Can we use the same element twice? You may not use the same element twice. Does the ordering matter? You can return the answer in any order. Great. So what I've really done here is clarifying a few things, right? And this is so helpful to me because I don't need to spend extra time crafting up a solution that would incorporate multiple solutions or even having like the same element twice. So great. And then I would probably even provide a couple more examples as well. So some sample examples of what I'd provide: a sample array of 2, 7, 11, 15, a target value 9, and the output here would be 0, 1 because of 2 plus 7. And then another sample array of 3 plus 3 equals 6, so that would output 0 and 1. Cool. And then the next step is thinking about the problem. So this is where knowing prior data structures and algorithms knowledge is going to come in really handy. Because essentially when you've practiced a lot of these kind of problems, what happens is essentially when you see like a problem, you're able to match it to a pattern immediately, right? So if it's like a graph-based problem that I encounter, I already know like that I need to use graphs, and then I've already narrowed it down to like what type of like graph search algorithm I need to use. And another thing to keep in mind is also verbalizing your thought process. Sometimes you might need a couple minutes to just sit and think with the problem if you're that kind of person, and that's totally okay, but I would just let the interviewer know that you need a minute or two to think about it. But if not, the expectation really is to be talking out loud through your whole process about like, what are you thinking about? What kind of like trade-offs are you thinking about, and why? Again, as you think through the problem, make sure you also think about incorporating edge cases into your solution, because it's easy to just like jump in and solve for the easy case, but ultimately you want to make sure the solution encompasses all different sort of scenarios. So for this problem, if I was verbalizing my thought process, here's what I'd do. I'd first tell the interviewer that I was thinking of a brute force solution. And that brute force solution would probably look like looping through each element I in our array nums, and another for loop within that for loop to find if a value target minus I exists. And that brute force solution would have a space of O of 1 because we're not storing anything, and a time complexity of O of n squared. But wait, hold on. That time complexity seems a little too much. Maybe I can trade some space for speed and implement a better solution. So in this better solution, what I do is use a hash table. And in this hash table, I'd add every value and the corresponding index to a hash table. And then again, I would check if that value target minus nums of I exists in our hash table. And if it does, that means we've found our answer. So in this case, even though our space increases to O of n, our time complexity is significantly reduced. So at that point, you'll probably have some clarification with the interviewer and most likely go ahead and implement the more optimized solution. Any football or soccer fans in here? Yeah? The next step is making a game plan. So what does this entail, right? I think it'll look different based on the problem that you get. The first option is visualizing the problem. And this is especially helpful if you have something like a graph, a tree, or a map-based problem. So basically, you would use a piece of paper, or these days, if you're using one of the online text editors, you can use their whiteboarding feature to essentially draw out whatever diagram might be helpful to solve the problem. But sometimes maybe a diagram wouldn't make the most sense. In this case, I would probably just write out some pseudocode, which is essentially a rough draft of what you'll be implementing. You know, essentially just a few bullet points of like the logic in just plain words. And at this point, if you're still stuck on the problem, it's totally okay to start with a brute force solution and optimize as you go. I will say it's better to keep going than to just stay stuck. So for this problem, I don't think visualizing the problem would make much sense, so I'll go ahead and write some pseudocode. And what would that look like? So I jot a few bullet points down. So the first thing, essentially what we talked about in the prior step into bullet points. So I'd have a for loop to go through every index in nums. I would take the difference of the value target and the value at the index. And then I'd have an if statement inside to check if the difference already exists in our hash map. And if that value is found, then that's our answer. So I would just return the index I and the index of the difference. And if that value is not found, then I would add the index and the value at the index to our hash table. Great. And the next step is coding or writing out your solution. The reason why I put right there is because prior to COVID times, most interviews used to be whiteboarding, but these days it's mostly done over a text editor online, so you'll most likely just be coding it out. But keep in mind, you'll want to spend the bulk of your time on this process. But the good news is the reason why we went through all those steps just now is to help you with this process, right? So if you went through all those steps, this should be like the easiest step to do essentially, because it's just a translation of what you did in the previous step of visualizing the problem or writing out the pseudocode. And as you implement your code, you'll want to explain every decision and trade-off. So as you're writing out your code, explain what you're doing and why are you implementing what you're implementing. And also, don't forget to make use of good coding practices. This is one of the most common mistakes I see because people feel like, oh, they're not writing code for an assignment or like actual work. But still make sure you make use of good coding practices. So that means writing out comments where logic might seem a little ambiguous, or breaking up large chunks of logic into classes and functions, or even having descriptive names for variables. So for my prior step, right, we just went through that and wrote down the pseudocode. So this step will be super simple because essentially we'll just translate what we wrote here in English to code logic. So if I were to write my solution in Python 3, this is what it looked like. I'd first start with the function definition, and then I'd pass in the inputs that were given. So in this case, that would be nums and target. And then also declare a empty dictionary because that's something we're going to need. And then start with the first bullet point, which is a for loop to go through every index in nums. So we just have a for index I that goes through all the indices in nums. And then the next bullet point, take the difference of target and the value at the index. So all we're doing is setting diff to target minus nums of I. And then boom, third bullet point, if statement, which essentially checks if the difference already exists in our hash map. Sorry, that should be on the prior line, but essentially if the diff is in our hash map, then all we have to do is return the value that we found on our index because we found our answer. And then second to last bullet point, if the value is not found, return the index I and the index of the difference. So that would be in our else block. So if not, then all we have to do is add the index and the value at the index to our hash table. And apologies for the formatting. It went slightly off screen, but I think you get the point there. Essentially what we're doing is adding the value, if we haven't found it in our hash map, to our hash map. Great, so writing our code was so simple because we already had the logic jotted down. Great, and I'm just gonna add a couple comments as well. It seems a little unnecessary for this code, but keep in mind that if you have a more complex problem, it's something you'd wanna do. And that brings us to our next step, which is checking our solution. So the main point of this step is checking for glaring logical errors, right? So another thing the interviewer is trying to see is if you can catch and fix your own mistakes. So there's a few ways to go about this. The first thing is just eyeing your code and walking through the code and explaining what it does to just double check if everything makes sense, right? But that might not necessarily work, especially if you have a more complicated problem. So the way to go about it is really to test it with 1 or 2 examples manually. So you can use the examples that you already came up with in the first step and just walk through your code and make sure you're getting the expected output you need. Again, from the first step, we clarified what our expectation was, whether we had to compile and pass test cases, right? So if you already had that expectation set from the beginning, it's good because you can calibrate yourself and pace yourself for the time of the whole interview, right? So if you need to compile and pass test cases, this is the step that you'd also do it at. So we have our solution here, and I'm just going to double check the logic by walking through a sample test case manually. And I'm going to use the exact same inputs we were given initially, right? I think it's totally fine to just, again, use one of the examples from the beginning. There we go. So the first thing is our for loop. So for I in range length of nums, so that would go through the values 0, 1, and 2, because those are like the indices of the entire array. We'd start with our first iteration, which is I equals 0. So in our first iteration, our diff would be 3. Why would it be 3? Because we have target minus nums of I, so target in this case is 6. And then we have 6 minus nums of I in this case would be 3. So that would be 3. And then we jump to the next line. We have the if statement to check if that value diff exists in our hash map. So currently our hash map is empty. So this should evaluate to false. Great. And because it evaluates to false, we directly jump to the else block and add the value to our hash map. And in our next iteration, we have I equals 1. And in this case, our diff would be 4. Why would it be 4? Because we have our target value, which is 6, minus nums of I in this case would be 2. And our if statement, again, evaluates to false because we didn't find that value in our hash map. So again, we jump to the else block. But we add it to our existing hash map, which already contains the value 3, 0. So we just add the key value 2 and the index value 1. And then finally, in our last iteration, I equals 2. Here, our diff would be 2 because we have 6 minus 4. But wait, actually, our if statement evaluates to true here because we already have that value 2 in our hash map. So essentially, we've found our answer. So all we have to do is return values 1 and 2. Great. So by walking through this example hand, step by step, we've found our answer. And we've double-checked that the logic works. And the last step is really evaluating and optimizing. So what does this step entail? The first part of it is evaluating the runtime and space complexities, right? And as you state these runtime and space complexities, there's a couple things you want to keep in mind. The first thing to keep in mind is stating the space and runtime complexity itself. But then you also want to mention what those variables represent. You simply don't want to throw out values like, oh, it's O of n squared, O of v plus e. You want to state what do the values n, v, plus e represent. And then additionally, you also want to explain how did you derive that value, right? I think it's really easy to fall into a trap where you're like practicing all these algorithms and you're like, oh, I know the runtime of that. But you simply don't want to blurt stuff out, and you actually want to make sure it makes sense in the context of the problem. And then the other aspect of this step is also going through optimizations. So sometimes there might be no more optimizations left, and I think in those cases it's fine. But in the majority of the cases, there's always something that you can improve in the code that you've written, whether it's minor or major. Or maybe in your first step, you started out with a brute force solution, and now there's a more optimal solution that comes to mind. So this is where you'll want to have that discussion with your interviewer. Sometimes there might be an expectation for you to implement the more optimized solution itself. But most times, it's honestly good enough to just simply have that discussion. But you'll want to make sure that you're talking with your interviewer about, like, what kind of trade-offs did you make in these algorithms or data structures that you implemented, right? And what kind of improvements can you make further? So for this problem, I would first state the time complexity, which in this case would be O of n. And n here represents the number of elements in nums. And the reason why our time complexity is O of n is because we traverse a list with n elements once with a for loop. And then within that traversal, we have a hash table, but hash tables support fast lookups almost near constant time of O of 1. So ultimately, our time complexity ends up at O of n. And then our space complexity is also O of n. Again, n here represents the number of elements in nums. And the reason why it's O of n, because we store all these values in our hash table, and we store at most n number of elements. And you can have some discussion again about like the optimizations. I'd probably talk about things that I mentioned earlier, where I'd compare it to the brute force solution, and how even though we increase the space here, we have a significant better runtime. And that's really it. But I want to give you a few reminders before you leave. And one being this tweet. When in doubt, ask yourself, what would Beyonce do? Would she apply for a job? Nope, she'd just show up one day like I work here now. So you've gotten all these tips, and you're going to put in all this practice. But the one last component that I want you all to bring in with you into your next interview is simply confidence, right? I think it goes a long way if you just go in with that confidence, because you've already practiced a lot, and now you know how to solve these problems. And a couple more reminders. Definitely look out for hints from the interviewer. My theory is that if the interviewer is mentioning something, it's probably because it's relevant to the problem, and not because that they're purposefully trying to trick you. And also, demonstrating interest in the company goes a long way. Definitely makes you stand out as a candidate. And prepare lots of questions. So even though most of the time will be focused on solving the problem, you'll have a few minutes at the end to ask the interviewer any questions about what it's like working there, what is the team like, what kind of projects do they work on. And of course, don't forget things like pen, paper, water, whatever you need. And a few resources to keep in mind. The first one being Cracking the Coding Interview by Gail Lockman McDowell, which might be a book a lot of you already use. But it's a great starting point because you can get a cohesive overview of like the most common algorithms and data structures necessary for these interviews. And you can sort of start there and figure out like what are your weakest areas, and then continue to work on those specific areas. And then also LeetCode and HackerRank, of course, especially LeetCode. There's so many problems that you can just use. And mock interviews. So there are a couple websites online where you can do mock interviews with other people who are also looking to practice. So a couple of them are Pramp and interviewing.io, but I know that there are a lot more out there as well. Glassdoor, really great for company-specific questions. My favorite one is Practicing with Friends, because they can give you direct feedback. And ultimately, no matter if you're practicing with someone else or yourself, don't forget to practice thinking out loud, because ultimately, that's like the one thing that everyone needs to get used to. And I know we have time for questions, but I want to make sure all those questions go answered. So if any questions go unanswered, feel free to reach out to me on Twitter. Again, that's my handle. And any questions?
Hi.
Hi.
Thank you so much. Thank you for breaking down something that scares a lot of us, and for going through step by step with us. Now, does anyone have questions? Okay.
Hi,
Hi.
thank you for your explanation. It was very good. I would like to ask you for you to tell us a little bit how was your hiring process at Twitter?
Yeah, definitely. So I could definitely break it down for you. Are you curious more about the internships or full-time hiring or both? Oh, both? Okay, cool. So let's go over it. And I can personally speak to my experience as well because I first started as an intern at Twitter and eventually came in full time. And these days I do a lot of interviewers for full time engineers and interns as well. So I can give you both perspectives. So I will say, again, the main thing really is just having a fundamental understanding of data structures and algorithms, right? Because when it comes to the technical things, ultimately that's what they're looking for. And I know there's a lot of debate on like what kind of like interviews tech companies should be doing, but you might be able to argue like, oh, like you don't use these leak code style questions in your like daily work, and that might be true, but ultimately that's what's going to get you in the door in the first place. So I would definitely focus on that first and foremost. As an intern for the interview, so I think there were 2 or 3 different rounds. I would say 2 of those 3 rounds are focused on like the technical portion of it. So you'll probably first have an initial phone screen. So that phone screen might just be like a problem that you need to solve online and submit, or sometimes it's with the interviewer online, and they give you a leak code style algorithms-based questions that you need to solve within like an hour. You'll have some brief time at the end to ask the interviewer questions, but again, you're evaluated on your technical skills in that very first step. Once you get past that first step, it's what they call an on-site interview. And this on-site interview as an intern is probably like 2 or 3 interviews. Again, 2 of those 3, or like the majority of those interviews, will be technical focused. So again, these kind of questions, you will have one interview that'll be more soft skills based. So that's talking about your resume, right? What kind of projects have you done? What kind of courses have you taken? Where do your interests lie? As a full-timer, it gets a little more complex because it definitely depends on the range of like your experience. So I would say if you're coming in as a new grad, fresh out of college, the interviewer will probably expect you to be maybe a little more advanced than the intern level, but it'll be pretty similar in style, where most of the questions are like leak code style-based questions. But as you get more senior or more experience, you'll also have other sorts of interviews thrown into the bag as well. So another common interview process is also called systems design. Have many of you do you guys know like what systems design interviews are? Okay, I can certainly go over it. So system design questions are essentially like a prompt that you're given about how would you design a certain feature, or how would you implement a real software engineering feature. So essentially they're looking to see like if you were to do this job in your daily life, like how would you go about that thinking process, right? Again, if you want to read up more about it, Cracking the Coding Interview book actually has a whole section on systems design interviews as well. This is something that you can Google, but that's something you can definitely do. But I would say if you're definitely still in college, definitely just focus on this stuff for your interviews. Yeah.
Okay, more questions? I can go here and then over there.
Great talk. Thank you so much. I was wondering, do you have any insight on interviews for site reliability, so production engineering? So it's still software.
Yeah, production engineering. Good question. I can speak a little to it. Personally, when I was in college, I thought about going to production engineering. My current line of work is very much on the systems infrastructure side, so I know what that's like. Again, I think for production engineers specifically, systems engineering in terms of like software engineering is very important. So I would definitely learn a little bit about distributed computing. So there is this very great book, you might want to write it down. It's called Designing Data Intensive Applications. I forget the author's name, but I can give it to you later. Designing Data-Intensive Applications, really good book, but also really dense book. But that pretty much goes through all the concepts that you'd ever need to know about like systems design or distributed computing. So I would just get familiar with those concepts. So a lot of the topics are related around like databases, how do you deal with essentially computing at scale? Because a lot of these companies, the main problem that they're trying to solve is like the problems that we solve daily, but at scale. Because when you consider that scale, it adds like essentially a whole new layer of complexities. So getting familiar with like distributed computing will definitely be helpful for production engineering, infrastructure-based interviews. But you honestly don't need to know a whole lot, especially if you don't have a whole lot of industry experience already, because a lot of that does come with just like being on the right projects or like just gaining that experience. But at least knowing like the basics will get you a long way.
Okay, next question.
Hello again.
Hi.
Imagine you live here in Portugal and you want to join an American company such as Twitter. How would you go about doing it? Would you move there first? How would be the process of hiring someone from Europe or outside the US?
Yeah, so I personally can't speak too much, but I do have quite a few friends from Europe who work at Twitter or even other really big tech companies, so it's definitely possible, and I think literally any of you in this room can do it. I think a lot of it is really just getting your foot in the door, which is like the main thing, right? So like doing whatever you can to get your resume noticed would be the first step. So for me personally, like even I went through a lot of that process myself in college, even though I was in the United States. So the thing I did was like get involved in things like this. So like being part of the SINFO team would be a great example because personally I organize hackathons in my college. So by becoming a hackathon organizer, I was able to develop all these relationships with like people in the industry, or like people see that you're like genuinely like passionate about something. I think a great way to go about it is to like demonstrate genuine passion in like some area related to tech. So for some people, that's research, right? So I know a lot of people who've gone into like AI research, and a lot of those people like worked with professors and made sure that they went to a lot of conferences so that they could get noticed where these companies are in the career fairs. Like for me, that thing was hackathons, right? So by going to hackathons, I got to interact with like all these companies. Because definitely, I would say the hardest part is just like getting your resume noticed. So put yourself in spaces where you're able to get that exposure. And once you get past that, I honestly think that they would be more than happy to hire anyone. I think the main thing that like companies are concerned with is mostly just like finding the right fit of people. So I would say as long as you can pass interviews and do them well, like these companies would be more than happy to hire you. Even if you're not from America, like they will, like I know Twitter and all the other big companies have like lawyers in-house that will help you get your visa. Like honestly, like all my team, except maybe like one or two of us, are all immigrants. Like none of them are like native to America. I think a few of them did go to university in America, but a lot of them didn't even attend university in America.
Okay, thank you.
Yeah.
Okay, any other question? Okay.
Thank you so much. Thank you so much for
Yeah.
your talk. What do you suggest when a person freezes during an interview?
What would I what? Sorry.
When a person block during an interview, freezes.
Wait, can you repeat it?
Like if you're stuck on a question, you're not sure how to answer the question, you're on a roadblock.
got it. Okay. Yeah, so if you're stumped on a question, I think, as I said earlier, the main thing is to just keep going, right? And the one thing that's really helped is to just really reframe your mind about how you approach interviews. don't think of interviews as assessments. Don't think of it like a test, you know, where you're like being interviewed by someone with more power and like, oh, you have to perform and like do well. Because in actuality, what that's just gonna do is just crank up your nerves. You're gonna feel really nervous, and then like you're not gonna be able to breathe and just really focus on what you need to. But rather, reframe your like thinking as like you're working or like you're collaborating with the interviewer to solve this problem, right? So if you were working with this person and you pretended like you were their coworker, how would you go about it? You'd probably ask questions if you were stuck, right? I think it's totally okay to just be honest and be like, actually, I don't understand this. Because at least if you're honest, the interviewer can give you more hints, and then they can guide you on the right path about like where you can do. And that's totally fine. Like I can tell you from my own personal experience, I've gotten stumped on many questions. I often have candidates that get stumped on many questions, but it'll get you way farther if you're just like honest or even ask questions about like, oh, what does this mean? I don't understand this. Can you please explain it? It's totally fine. I know sometimes, like, oftentimes I've even had to use like Stack Overflow in the middle of like an interview. I would just like explicitly state it to the interviewer. I would just be like, oh, like I actually don't remember how to implement this. Do you mind if I look it up? And most oftentimes they're like, yeah, go ahead. So that definitely helps.
Thanks.
Yeah.
Okay, any other question? So maybe now we're gonna pick the winner for the session.
Great.
Thank you so much, Shubha, for this
Yeah.
talk. It was amazing.
Thank you so much, everyone. Yeah, I just wanted to say it's such an honor being able to present here, especially after so long with COVID and all. Also being in Portugal for the very first time, beautiful city, by the way. And kudos to all the organizers for putting this together because this isn't easy. And to you all for showing up. So thank you so much.